last test, the first page?
Yeah,
Which one?
It doesn't matter. Just find the domain.
Oh, so you don't want the first page?
You gotta find the domain on the first page. So.
No. The least common denominator on the first page? No. You're not adding or subtracting. So you want to find the least common denominator?
I said domain.
Oh, domain. Oh, I'm sorry. Yes, yes, yes. Yes, I don't know. Yep. I feel tired. It's the end of the semester, but there's no excuse. I'm sorry. So for this function, or rational expression, I have to arrange it in this form, of course, and then write a restriction. X cannot be -7, and only then I can write 1 and 1. I saw it in your test. If you did not write 1, you completely changed the final answer. So I'm not particular on any particular item on your test, but if you don't write 1 and 1, you may change the answer. So it's important to do that. So then the domain of this function is -∞, -7, union -7 to infinity. Yeah, we've been doing this since chapter 8, actually. Right? If you go back to your notes, you will find it. Now for, let's say, for the next one, in which I have x cubed plus 7x squared, everything divided by x squared plus 5x minus 14. Then I will factor the numerator, x squared and x plus 7. I will factor the denominator in x plus 7 and x minus 2. I will write two restrictions, not -7 and not 2. Only then I am allowed to simplify, and then I write x squared over x minus 2. But when I write the domain, I have -∞ to -7, union -7 to 2, union 2 to infinity. In plain English, anything but -7 and 2. And on the last one, any questions on this? Okay, but this is really routine. At this point in time, I'm hoping that you got to the point in which you say, oh, okay, so now between now and Wednesday, if you redo each test at least 3 times, you should be able to say, everything is easy. I'll ace this. At least 3 times each test, at least. And I wouldn't do just those tests. I would go back at the end of each chapter and I will redo the test of that chapter. I recommend that, sure.
Can I say
Just, yes, of course. Don't forget what you want to say. In 1 second. Any questions on this? Okay, so then I will rearrange everything at the top. And then x squared minus 4 divided by x minus 2. And then I factor x plus 2 and x minus 2. And then x minus 2. Of course, x cannot be 2. And now I can simplify it. So this is what we did in chapter 6. I have to rearrange it in descending order. I have to factor out -1. I have to factor x squared minus 4. I have to state restrictions. I have to simplify and write the final answer. So the domain is this. When you said domain, I was thinking of common domain for some reason. The least common domain. The least common denominator. I'm sorry? Yes, 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 of course. I'm sorry, Brielle. Bless you. So that is 17 over x squared plus 8x. So,
I didn't set part of it outside, but.
so 17 divided by x squared plus 8x.
Plus 16.
And then minus or plus?
Plus 2 over x plus 4.
Very good. So here we are asked to add two rational expressions. I will have to factor the denominator of the first one, which is x plus 4 everything squared, and plus 2 over x plus 4. Any questions, by the way? Any questions on the previous problem? Any questions on the previous problem? Are we okay with the previous one? Okay, perfect. So now here's another problem. We are asked to add these two rational expressions. So I factor the denominator into x plus 4 squared. This has the denominator x plus 4. And now I'll find the least common denominator stating only one restriction. So what would be the least common denominator in this case? X plus 4 squared. Very good. Good. So now I need to find adjustments for the top of each fraction. It will be a terrible mistake. I know you're not going to do it, but I'm just explaining 17 plus 2. Writing 17 plus 2 here will be a terrible mistake. So what is the top here? What does it need?
1.
1. Very good. What does this one need? Very good. And now please dictate the numerator.
17 plus 2x.
Very good. So the simplified form will be 2x plus, is it 25? Divided by x plus 4 squared, including the restriction.
How do you know it's multiplied by 1?
Because it has already the same denominator, it doesn't need anything.
Okay.
Yes?
Can you give us an example about what's it called? Imaginary numbers.
Yes. You want to add, subtract, multiply, power of I. Good. Here it is. I don't think I can surprise you, but okay, so what do you think we're asked to do here? Absolutely. These are two complex numbers. We are asked to divide them. Excellent. Perfect. So then what do I do? Very good. Multiply by the complex conjugate. Very good. The denominator is easy. We are using the same formula. It's 1 minus I squared. But the top needs work. 3 times 1. 3 times negative I. Negative 2I times 1. Negative 2I times negative I. What do I need to do next? Not yet. Into. So then the numerator becomes 1 minus 5I, and the denominator becomes 2. I have to separate it. 1/2 minus 5/2 I. Very good.
Can you do a problem with like when it's like I to maybe 300?
Yes. You come up with any number you want. Very good. So I to 300 is a nice number because it's I squared raised to 150. I divided 300 by 2 because that's all I know, I squared. So then this is negative 1 raised to 150, which is 1. I only have I squared. There is nothing else available to me. So since you chose an even number, I divided by 2 and I replaced it by I squared to 150. If you had given me an odd number, I would have split it into,
Can you do an odd number?
yeah, just give me any odd number. I cannot have a negative number.
Hey, Professor,
Yes,
can you explain that concept one more time? You say
I only have I squared available. So I can present I to 300 using I squared. So I divided 300 by 2, so I have 2 times 150. I squared is -1. -1 raised to an even number is 1. So you said I to 55? Okay, so this is I times I to 54, and I apply the same procedure. I to I squared to the power of 27. So this is I times -1 to 27, which is I times -1, which is -I. Same procedure, I just took an I out of I to 55. Everything else is the same. It's I to 54, I replace it by I squared, I divided 54 by 2, and 2 times 27 is 54. I copied I replaced I squared by -1. I'm taking it to the 27th power, is a negative number raised to an odd power, so it's -1. Multiply these two, I get -I.
How did you get the first part versus I times I squared to 27?
In the same way I got I squared to 150, I got this one to be I squared to 27. 2 times 27 is 54. 54 divided by 2 is 27. 300 divided by 2 is 150.
so you just trying to make the statement true.
That's the only I only have I squared. I have to make use of it. And since this is 55 and it cannot be divided by 2, I had to take an I away. So it's an I times I to 54. I divide 54 by 2 to get power 27. I replace I squared by -1. -1 to 27 is a negative number. Better? Perfect. Anything else that you think of? Very good questions.
People probably are going to use the chart to find the
Yes. The domain or solving an inequality.
inequality.
Excellent. Very good. So let's look at -x, x minus 1, x plus 3 greater than or equal to 0. So we have 3 factors. I have -x, I have x minus 1, and I have x plus 3, and I have the whole product, -x, x minus 1, x plus 3. Now, which numbers go in the chart? Not any number, but we know only 3 specific numbers will go in the chart.
0,
Yes,
1, and negative. So -3.
-3, 0, and 1. Very good. For -x, the 0 is at 0. For x minus 1, the 0 is at 1. And for x plus 3, the 0 is at -3. And then, of course, the product will be 0. Anytime a factor is 0, the product will be 0. Okay, these 2 functions are linear functions with the positive slope, so they will look like this, meaning from negative to positive. But this one will look like this, from positive to negative. And now I count. In the first subinterval, 2 negatives. In the next subinterval, I count 1 negative. In the next subinterval, I count 2 negatives. And in the last subinterval, I count 1 negative. Better? Perfect. So now I know what to choose. I can only choose positive, because only positive is greater than or equal to 0. So this is the positive, and this is the positive, but of course I have to choose the corresponding x values. So x in the interval -∞, -3 with a bracket, union 0, 1 with a bracket. Next question. Very good questions. Yes, next question, please.
Let's solve the equation.
Yes.
2 parentheses 4x minus 3 squared.
Like this?
Yeah. Minus 9 parentheses, no, I'm sorry, parentheses. 4x minus 3 minus 5.
Good. So I will do the same thing. Let t be 4x minus 3. So this new equation becomes 2t squared minus 9t minus 5 equals 0. Exact same procedure as with the x to the 4th. Were you able to follow so far? Okay, so then 2 times negative 5 is negative 10. So 2t squared minus 10t plus t minus 5 equals 0. I factor by grouping 2t, t minus 5, and I need a t minus 5. And now I look, and it's positive 1. So therefore we have t minus 5 and 2t plus 1. And we have two options in t, 5 and negative 1/2. This is good, but it's not good enough. Why isn't it good enough? Because I did not solve for x. I only solved for t. Any questions? Any questions? So now, can anyone dictate this equation? And then this equation? Equals 5. Excellent. And then this one is? Excellent. So I'm adding, say it again. I'm adding 3, so I get x equals 2. And I'm adding 3. 3 minus 1/2 is 5/2. And then I divide both sides by 4, but I'd rather say that I'm multiplying both sides by 1/4. It's easier to multiply than divide. So I have x equals 5 divided by 8. 5 divided by 8. Very good pick. Yes? No, because we did not take, very good question. We did not take, raised both sides to power. We did not. But when we do, when we solve radical equations, yes, I have to. Very good. Yes, next question, please. Anything else? No, it won't let me put in the link.
That's the question.
Anything else that you want to look at?
Give me a second, please.
I'm not going anywhere. To be here till 9 o'clock tonight.
You're another class?
Yes, my pre-cal class. A student from my pre-cal class is nominated. We'll see. We have 2 more days till we get the final answer. Is nominated to be the valedictorian at the commencement.
Oh, nice. Who, your son?
No, one of my students. I wish. I wish he were my son. No, one of my students from the pre-cal class.
I have a
Yes,
question.
yes,
This is from test number 2.
yes. Ready?
Question number 5B.
Yes.
So it says the absolute value of 2x minus 1 plus 2, but it's not a right? Square root of x, that's x minus.
It's not the absolute value. It's the square root. Okay, very good.
Equals x.
This? Okay, very good. So let me delete this piece here. Let me read this back to you just to make sure we copied it correctly. The square root of 2x minus 1 outside of the square root plus 2 equals x. Perfect, just making sure. Okay, so this is a radical equation. So this is the square of 2x minus 1 equals x minus 2. And then when I square both sides, the left-hand side is 2x minus 1. What do I get on the right-hand side? And one more time, if you write x squared minus 4, I cannot give any credit for the problem.
X squared.
Yes, x squared.
That's the 4x
Plus
plus 2.
4x.
4, yeah.
Very good.
Oh, that's good.
Good. So now we subtract 2x. So this is x squared minus 6x. And we're adding 1. Because if you remember, from January 18th, we keep talking about this. Right? So then I factor. And I get x minus 1 and x minus 5, right? And then I get x equals 1 and x equals 5. And this, yes, I have no idea. Yes. So let's say this is the original problem, 2x minus 1 plus 2 equals x. And I plug in 1. Bless you. I know that 1 cannot work. Here's how I know. This is a positive number, plus 2 cannot equal 1. The square root, we know the graph. It's from 0 to infinity range, right? This is always a positive number. Right, so 3 equals 1, no. So this is not acceptable. So now I have to check 5. 2 times 5 is 10, 10 minus 1 is 9, the square root of 9 is 3, 3 plus 2 is 5, and I'll say yes. X equals 5 is the only solution. Very good pick.
Anybody else got a question?
Say it again. Log, excellent. Very good. Here's an example. Log 2x equals 7. How do I solve this equation? Very good. 10 to the 7th equals 2x, so x equals 10 to the 7th over 2. Excellent. What if I have the same thing with ln? What would be the base? 14, 15, 16. Yes. Indeed. So if I have, let's say, natural log x plus 1 equals 2, I have to write that x plus 1 is greater than 0. If we remember, natural log is not a friendly function. This quantity that we apply natural log to must be strictly greater than 0. So if I don't get a solution that is strictly greater than -1, I cannot accept it. So then, perfect, how do I change this? E squared, very good, equals x plus 1. So x equals e squared minus 1, which is a positive number, way bigger than, I shouldn't say way, but bigger than -1. So that is the final solution. Very good.
Yeah.
Yes, wonderful. Please.
X squared.
Yes?
7x minus 1 you get 0. I guess I don't understand how you get the fractions. I mean, it's in the notes, but.
Very good. So x equals -b plus or minus b squared minus 4ac over 2a.
You just want to put it in the quadratic form?
There is nothing else. It's not factorable.
Okay.
So -b plus or minus the square root of b squared minus 4ac divided by 2a. So then x equals 7 plus or minus the square root of 53 over 2. Yes, please.
That's the final answer.
This is the best thing ever
This one.
when my students do the review. That is the best. Okay, so we have here the cube root of 2xy squared times the cube root of 4x to the fourth y to the fourth. Perfect. So I'm allowed to multiply radicals as long as the radicals have the same index. So in this case, they do have the same index. So then I have the cube root of 8 x to the fifth and y to the sixth. Is this step understood?
Give me a second. Let me copy this. Yeah, we got it.
Agreed? Perfect. So now I will separate it. The cube root of 8, the cube root of x to the fifth, and the cube root of x, not x, but y to the sixth. And I like this one because it's 2. I like this one because it's y squared. It's 6/3, right? But I don't like this one because I have to split it. And I have to split it in x cubed and x squared. Because 5/3 is not an integer, 4/3 is not an integer, and I have to stop at 3. So then I will write this, this, and this. Yes. 2xy squared, and this has, yes, the cube root of x squared, indeed.
I don't know.
Yes, of course.
So let's pass this up. The last one, extra credit.
Any questions? Sure.
Some of this love.
So the square root of x plus 9 equals 2 plus the square root of x minus 7. So the square root of x plus 9 equals 2 plus the square root of x minus 7. Good. So it has two radicals. The radicals are separated. That's the easiest thing to do. It's easier to square. And then the left-hand side is x plus 9, and I would like you to give me the right-hand side. I agree with 4.
So 4x.
X minus 4. X minus 7.
Plus 2 square root of x.
2 times 2 times the square root.
So it'd be 4
X squared.
square root of x minus 7. And then x minus 7.
Right?
No, it's not right. I don't know where you got it.
Oh, man.
It's,
That was so long ago.
I know, but we did it every time we met.
I just forgot.
Okay.
But if you square exponent going over, because one of those and when it eliminates the
So this is a squared. This is 2 times ab. And this is b squared. 2 times 2 is 4 times the square root. 4 the square root. Plus the second term squared. Yes, I'm sorry, Letty. Go ahead.
I just don't. Just,
How many times, honestly? Can you give me a number? Or how many
I've
times?
definitely been emphasizing that a lot.
Okay, can I say infinitely many?
No, you exaggerated if you say that. You said it multiple times.
It's,
I got your point, though.
it's
I got your
infinity to the second power.
But so I'm just trying to get to
Good.
the part where you have the square on top. Don't that eliminate, because you have the square already on the outside, the parentheses, don't that eliminate the square root sign itself?
On this side, when I have one term.
Oh,
But not on
okay.
this side, where I have 3.
Makes
And the
sense.
middle one still has a radical.
That makes sense.
So now I subtract x from both sides. 4 the square root of x minus 7 stays on the right. 4 minus 7 is negative 3. And negative 3 moved to the other side is 12.
Combine it.
Then you square both sides.
4 minus 7 is negative 3. I add 3 to both sides and I get 12. And then I copy this term here.
You might square it.
No. I will divide both sides by 4 to make my life easier if I can. So this is x minus 7, and only now I square again. And I get 9 equals x minus 7, or x equals 16, and of course it comes with a big question mark.
How did you get 12?
Okay, 4 minus 7 is negative 3. Negative 3 added to both sides is 12. Good. So now I have to go back and check back to the original problem, and this was the original problem. And by the way, you have this problem solved in your notes. I took it from the notes and I put it on the test. So yes, if you go back, you'll find it. It's in your notes. Before the test, 16 plus 9 is 25. The square root is 5. 16 minus 7 is 9. The square root of 9 is 3. 2 plus 3 is 5. And I will say yes.
So the final is open
Yes, and there are 3 lifelines.
Um,
And the cell phone. And the computer. No, nothing. You
$1
didn't hear anything, and you're better off by not hearing anything. Yes. I didn't say anything valuable.
And $1 million. So you
No, it didn't have any value at all. Good. Next question. Anything else? This is the best review with any class I've ever had before.
you get actually 10 points on the.
Maybe even 20 if you negotiate harder.
Okay, so
Okay, we still have 20 minutes or so. So let's work on other problems. Let's use the time efficiently. Steph, say it again. Yes, excellent, good, good, very.
The one that was on the test one, it was like extra credit on test one. Right?
Extra credit on test 4. We already did that. We did that, the extra credit on test 4.
Maybe it was
Jen, we did the extra credit on test 4 a few minutes ago.
Yes,
Okay,
that's what I had asked.
thank
you meant test 3?
I don't know.
We did that too.
I don't know.
Oh, you did that too. So what? I know what you mean. So let's do this. So we have A equals H times A plus lowercase a, lowercase a, lowercase b, everything divided by 2. We're asked to solve for lowercase b. Yes, of course, I will multiply everything by 2. I agree.
You have to distribute your H.
You don't have to, but it's not a mistake. I would get rid of it. I agree. So 2a over h equals a plus b. And now what do I do?
You subtract that.
Very good. So b equals 2a over h minus a. Very good questions. Anything else that you think we should go back to?
What happens if we have questions like outside of class, like before on top of?
Yeah, I'll be here. I'll be here.
Like here at school, I don't know what's happening at school.
So our final is between 2 and 4.
That's not what I meant. So we have to do it Wednesday, we have to answer our questions Wednesday, like what if you come some like on the weekend or something, how do we get in contact with you about our questions?
You have my cell phone number.
We do.
Yeah. It's on the front. It's on the front page. I got a lot of I can show you the text messages that I get with different questions. I just got one 3 minutes ago. Here it is. Just 3 minutes ago.
I remember one day I told
Right
her,
here.
I said, well, she must don't work on weekends.
Yeah, I don't know how to show it to you. Just 3 minutes ago.
We just send you a picture of your text.
Yeah, you can.
You have to Uber. Tango.
If I am available over the weekend, I will always answer.
You guys never use that.
If I'm in the middle of something, I'm away from my cell phone, we will take.
And then Wednesday on our final exam, are you here anytime before 2 o'clock?
If you email me or text me and say, Professor, I want to see you 20 minutes, 15 minutes, I have 3 questions or whatever, I'll be here earlier. Yeah. Anything else? Anything else? Yes. Yes, the direct, inverse, and joint. Very good. That's at the end of chapter 8. End of chapter 8. Where are you, chapter 8? Right here. Yeah, chapter 8.
I think it was even 36 or 50 on page 295.
That's not what I meant, but
Oh, that's not.
okay, let me write it down. Which page 295, what?
Just kidding. Hold on. I have second. You have your book?
Yeah.
But I don't know, I got a couple of things circled, but I'm not sure which one.
Okay, tell me what it is and I'll look it up. But allow me to answer to Steph's question first and then. Yes. The horsepower to drive. So these two? The 95? I'll take a look. It's 36 and 50. And which one? Yeah, anything from here?
44. I'm not sure which problem it was, but it was something that had to do with stuff.
Page of 525. Okay. And anything else?
I think that was it.
I posted solutions for this, right?
Yeah, I'm just
Okay.
redoing.
Okay, very good. That's a very good idea. Okay, so let's work on 71 first. On page 544. The horsepower to drive a boat varies directly as the cube of the speed of the boat. The horsepower varies directly as the cube of the speed of the boat.
Which page is this one? I see you got a couple of them.
We're not talking about these yet.
Oh,
That's what I meant.
Okay? So, can anyone give us the equation?
Wait, can you read it again?
Yes. The horsepower to drive a boat varies directly as the cube of the speed of the boat. Very good.
So would that be H equals K S?
Excellent. And now I can read on. If the speed of the boat is to double, so instead of the speed, I have twice the speed. Determine the corresponding increase in horsepower. It's okay. So then we're asked to find the horsepower if we replace S by twice S. Can anyone dictate? What should I write? What do I have to write? K.
To the third power.
What is how does K get the third power? I don't get that.
Times 2.
Times
2.
2S, everything cubed. Very good. So then H equals K multiplied by. You have to eliminate parentheses, right? Of course. 8S cubed. Very good. So then H equals 8KS cubed. And now compare these two. So this one with this is the horsepower with S. But this one is the horsepower with S doubled. So what is the difference between these two? What do you notice? 8 times as much. Very good. So if the speed doubles, the horsepower gets multiplied by 8. So when speed doubles, h gets multiplied by 8. Gets multiplied by 8. Now let's look at page 295 and let's see what, yes,
So with 2, right? 2s, that came from where?
from the problem.
Because it's a double.
S is doubled. Doubled means, yeah. Page 295, let's take a look what's happening there. 294, 295. Okay, so problem 50 we just did a few minutes ago. Problem 36. Yes, the one with the mixture of nuts. You want to do that again? No? Okay. And page 525, let's look at 525. 525. Let's look at 525. You selected 44. Okay. Use the graph to approximate the total enrollment in fall in 2008. Is that what you meant?
No, don't do that one either.
Okay.
But can you do one
Yes.
when you have to solve for K and then you have to figure out?
Yes. 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 So let's go back to the end of chapter 8. Okay. The maximum age, so problem 26 on page 543. The maximum weight that a circular column can hold is inversely proportional to the square of the height. So, the maximum weight that a circular column can hold is inversely proportional to the square of its height. Correct? Very good. So then what would be the relationship between these two? So you said W equals? Very good. Excellent. So now I read on, and it says, if an 8-foot column can hold 2 tons, what is this for? So then 2 equals K over 8 squared, or 2 equals K over 64. So then K equals 128. Now we know how to cross multiply in a proportion. I have to go back and put it back in the equation. So now I have to write that W equals 128 over h squared. And now I can answer the question. Find how much weight a 10-foot column can hold. So this is, you can write 1.28. Okay, let's find the joint. Problem 40 on page 543. The number of cars manufactured on an assembly line at a General Motors plant varies jointly as the number of workers and the time they work. So the number of cars varies jointly as the number of workers and the time they work. So anyone can tell us a relationship that will connect all these three. Very good. And now we are told that if 200 workers can produce 60 cars in 2 hours, then this information is used to find K. So I have 60 equals K times 200 times 2. So K equals 60 divided by 400. And I simplify, so K equals 3 over 20. Have to put it back in the problem. So N equals 3 over 20 WT. And now let's see what they want. How many cars 240 workers should be able to make in 3 hours? So therefore N equals 3 over 20 times 240 and times 3. Simplify by 20 and I get 12. So say it again. Okay, very good. 108 cars. Any questions?